Hi there. This lesson, I'm going to teach you how to prove by mathematical induction. So let's go straight into it. First one. So use mathematical inductions to prove that for all positive n, the statement below is true, right? So for all positive n, so this means that n is starting from 1, okay? Greater or equal to 1 because it's all positive n. So that is n is equal to like 1, 2, 3, 4, 5, and so on, okay? So to prove this statement is true, before I do this, so let's just have a look at the statement first, okay? So we can understand a little bit more. So for example, so when n equal 1, so this means that on the left hand side is equal to 3. And on the right hand side, every time we see n, we need to replace with 1, like that. So that means 1 times 2 lots of 1 plus 1, okay? So that means on the left hand side, we have 3. And on the right hand side, we have 1 and then 2 times 1 plus 1. So this means that 2 times 1 is 2 and 1 is 3. So 1 times 3 is 3. So that is 3 is equal to 3. Then when n equal to 2, so let's say if n is equal to 2, so this means that on the left hand side, we have the sum of the first two terms. So term 1 and term 2 because n equal to 2. So 3 plus 7 equal to 10. So on the left hand side, we equal to 10. And on the right hand side, of course, with n, we replace with 2. So that is 2 open bracket. So 2 lots of 2, which is 4. And we add 1. So this means that 10 is equal to, this is 5. So 2 lots of 5 is 10. So there you go. And then when n equal 3, so we have on the left hand side, we add 3 and 7 and 11. And on the right hand side, we substitute the n with 3 and so on. Okay? And then if 4 and 5 is do the same process. So to prove the statement by using mathematical induction, we have to go through 4 steps. So let's have a look at these steps. So step number 1, okay? We need to show the statement is true for n equal 1. And then for step number 2, okay, we assume that the statement is true for n equal k. Now step number 3, we need to prove the statement is true for n equal k plus 1. And for the last statement, so we need to write a conclusion. So that is, therefore, the statement is true by the principle of mathematical induction. So let's go back to the example. So step number 1, we need to show it is true for n equal 1, right? So we just write proof n equal 1. So that is, on the left hand side, we have 3. So on the right hand side, we replace n with 1. So that means 1. 2 lots of 1 is 2. We add 1. So that is 3 equal, this give me 3. So 1 times 3 is 3. So the statement is true for n equal 1. So therefore, the statement is true for n equal 1. So second step is we assume that the statement is true for n equal k. So this means that we need to replace n with k because n is equal to k. So we just substitute n equal to k into the first statement. So that is 3 plus 7 plus 11. 4k minus 1 is equal to k. 2k plus 1. And the next step is we need to prove n equal k plus 1 is true. Okay? So proof for n equal k plus 1. So this means that we need to write all the way to k plus 1 on the left hand side. And on the right hand side, we just substitute n equal k plus 1. So on the left hand side here is k terms. So but we need to write up to k plus 1. So we write this statement and add one more term extra because we need to write up to k plus 1. So with this last term is we substitute n equal k plus 1. Okay, so I just write it out first. And we add the last term, that is k plus 1. So we replace and the last term with k plus 1. So which is at 4 k plus 1 minus 1. And on the right hand side, of course, we need to replace this with k plus 1. Okay? So that is equal to k plus 1 and 2 lots of k plus 1 and we add 1. Now on the left hand side, this one here is equal to this. Okay? So which is k times 2k plus 1. So I just write that out. So this one here is k 2k plus 1. Now I just write it out again. Okay? So that is k 2k plus 1 and we add that, write that out of course. So add 4 k plus 1 minus 1 which equal to the right hand side which is k plus 1. Now I just time this in, that give me 2k and time this in, give me plus 2 and plus 1, so plus 3 altogether. So now I just need to simplify the left hand side first. So I just expand this first, so that give me 2k squared and this time together give me k and we add 4k plus 4 and then minus 1. And on the right hand side, I just write this out. So k plus 1, 2k plus 3. So now I just simplify a bit further. So that give me 2k squared plus 5k plus 3, which is equal to k plus 1 and then 2k plus 3. Now I can expand the right hand side, this one here, so that I can see the equal left hand side, or I can factorize the left hand side. So let's factorize the left hand side. Okay, so I just go 2 times 3 is 6. So I just write this down first, and then we have a positive there, and we have the coefficient of k squared is 2. So I just write 2k plus, because this is plus, and copy this out. So 2k plus and 2k plus, and I divide by 2 of course. Now if you need to practice on factorizing, I have put the link on the description below, so please go and practice though if needed. Okay, so what give me 6 and then add up give me 5, so 2 and 3. So I put 2 there and 3 there. I take the 2 out and I cancel this, that give me 1. This cancel that, so that is k plus 1 and 2k plus 3, which equal to k plus 1 and 2k plus 3. There you go. So they are equal. So we just write therefore we need to write the last statement, that is therefore the statement is true for all positive integer n. There you go. That's how you do it. So now please pause the video and try this one yourself. Right, let's go through it together. Now, first statement, we need to show it is true for n equal 1. So I just write proof for n is equal 1. So this means that on the left hand side, so when n equal 1, we have this. So that is 1 is equal to, on the right hand side, we just replace n with 1. So 1, 3 times 1 is 3. So that is give me 1. So 1 times 1 is 1. So therefore 1 is equal to 1. So we write therefore it is true for n is equal to 1. Then the next step is we assume that it is true for n equal k. So this means that we just replace the statement with k. Now we need to prove for n equal k plus 1. So this means that we write all the way to k terms, that is k terms, and one term extra, that is k plus 1. Okay, so I just write it out. That is up to k term, but we need to write one term extra, that is k plus 1. So we just substitute k plus 1 here. So that's what that meant. Okay, so just write underneath here. So add 6 k plus 1 minus 5, that is term, and on the right hand side we just substitute that in there, so which is k plus 1 and then 3 lots of k plus 1 because n is k plus 1. Okay, so now I just simplified it, and these terms here is this one here, so I just write here k 3k minus 2. So I just rewrite it out. On the left hand side is k 3k minus 2 plus 6k plus 1 minus 5 is equal to k plus 1 and 3k plus 1. There you go. So now we just need to simplify a bit more. So I just expand this out. So which give me 3k squared, this time together minus 2k. And this time together plus 6k. And this time that plus 6 minus 5. So this one on the right hand side, I do the same thing. I just simplify. So 3 times k is 3k. And 3 times 1 is 3. And then we minus 2, so become 1. And on the right hand side, of course, I simplify further and I factorize, okay? So to make it equal to right hand side, that's the whole point. So to factorize the left hand side, so I just do out here. So this time together give me 3. So what give me 3? And add to give me 4 because it's numbered there. So 3 and 1. So I take the 3 out, that cancel. So this is it. So that is k plus 1 and 3k plus 1. So now just write it out. So on the left hand side is k plus 1, 3k plus 1, which is equal to, there you go. They are equal. So now we just need to write it out. So first one is we say therefore it is true for n is equal to k plus 1. Then we need to write the last statement. So we write, therefore, the statement is true for all n greater than or equal to 1. Because they give us the domain is this, okay? There you go. Thank you so much for watching. Bye.